Hello everyone. In this video, we are going to talk about another problem from International Mathematics Olympiad. This comes from Hong Kong 2017. Let's assume that d1, d2 until dn are positive factors of 11 factorial. We want to find sigma 1 over di plus SQRT of 11 factorial for I is equal to 1 to n. Before moving to the solution, make sure that you pause the video to think about the problem. To solve this problem, let's start with some assumptions. Basically, we know d1, d2 until dn are all positive. We assume that d1 is the smallest value, d2 is the second smallest, and then finally dn is the largest values that we can have from d1 to dn. Also note that 11 factorial is the product of 1 to 11. So we can write it as 2 to 8 times 3 to 4 times 5 to 2 times 7 times 11. Now remember, for each positive integer greater than 1, we can write it as the product of its prime numbers in a unique way. Now, if we have an integer n and we write it as the product of prime numbers, then for n we can write it as a to the power of alpha times b to the power of beta, so on and so forth. Then the total number of factors that we can have for n is equal to alpha plus 1 times beta plus 1, and then so on and so forth. If we use this property for 11 factorial, then we can find a small n as 8 plus 1 times 4 plus 1 times 2 plus 1 times 1 plus 1 times 1 plus 1, which is 540. Let's continue the discussion with an example here. Consider the number 30. The positive factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Remember, we wanted to sort them from the smallest to the largest, and we did that here. Now we can write 30 as the multiplications of its factors in different ways. For example, 30 can be written as 1 times 30, 2 times 15, 3 times 10, or 5 times 6. Now we are going to use a new notation here. We write 11 factorial as the product of two factors. The first one is dj, and the second one is dn plus 1 minus j. Here j is in the range of 1 and n over 2, including those numbers. For example, for j is equal to 1, we can write 11 factorial as d1 times dn. Now let's continue the solution. In the original equation, we have 1 over d1 plus SQRT of 11 factorial, and the second term is 1 over d2 plus SQRT of 11 factorial, so on and so forth. We first rearrange the equation to have d1 and dn together, d2 and dn minus 1 together, and dj and dn plus 1 minus j together. To be able to simplify the equation, we need to focus on one term for now. This term has two parts. The first part is 1 over dj plus SQRT of 11 factorial, and the second part is 1 over d n plus 1 minus j plus SQRT of 11 factorial. We need to add these two parts together. If we do so, and then just simplify the addition, then we are going to end up with two terms for top and bottom of this division. On the top, we have dj plus dn plus 1 minus j plus 2 SQRT of 11 factorial, and for bottom we have dj times dn plus 1 minus j plus dj plus dn plus 1 minus j times SQRT of 11 factorial plus 11 factorial. Remember, dj and dn plus 1 minus j are factors of 11 factorial. So if you multiply them together, you get 11 factorial. And then you can see top and bottom of this division actually have something in common. If you factor out that and then remove it, you can simplify this equation to 1 over SQRT of 11 factorial. From here, everything is very straightforward. Remember, we wrote the original equation as sum of some pairs, and for each pair we found the final answer is going to be 1 over SQRT of 11 factorial. If you do so and count number of pairs that we have, you will end up with n over 2 pairs. Each one is 1 over SQRT of 11 factorial. So the answer is 540 for n over 2 times 1 over SQRT of 11 factorial. And that's our answer. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel.